All right, for 1.8 in Algebra 2, we are doing absolute value equations. So our objectives are to solve absolute value equations, write absolute value equations describing graphs and real life situations, and also to use the distance and midpoint formulas to solve problems. All right, so the equation, the absolute value of x equals 3, can be interpreted as x is 3 units from 0 on the number line. Now this may sound like really ridiculous and unimportant, but it's actually important. Okay, so this equation, the absolute value of x equals 3, means x is 3 units from 0 on the number line. Okay, because therefore x must be -3 or 3. So the number inside here has to be -3 or +3. Okay, so the graph of the absolute value of x equals 3 would be as follows. We would graph it here, that x equals -3, or here, that x equals 3. Okay, because it can be either of those two things. All right, so example 1, we want to interpret the absolute value of x equals 2 in terms of distance and graph the solution. Okay, so in terms of distance, we want to use this phrase right here. Okay, that phrase up there that we talked about. So we're going to say, well, that means that x is 2 units from, that looks weird, 0. Okay, so we can say x is 2 units from 0. And to graph it, that means, okay, if x is 2 units from 0, x can be 2 or it can be -2. So we would graph -2 and 2. Again, that might seem like really simple and kind of ridiculous, but you have to understand that it means that x is blank units from the number line, or from 0. Okay, because we're going to apply this to solving equations. So let's go on down to the next part. All right, so I'll move my box. The absolute value, okay, or we have the symbol for what that is, right? We've got our absolute value with x in the middle, equals x if x is greater than 0, and it equals -x if x is less than 0. So what it's saying is the number in here can always be positive or negative. Okay, it can always be either one. So this definition can be used to solve equations, such as the absolute value of x equals 6. And so what that's saying is, if x is greater than 0, then x is 6. If x is less than 0, then -x equals 6, and x equals -6. Okay, so that's the other thing. We can kind of jump to that one. But really it is saying, right, x could be a positive x inside there, or it could be, x could be a negative number. We don't know if it's positive or negative. Thus, we might say x equals positive or -6. Okay, so then we've got 4 steps to solving absolute value equations that we'll apply in example 2, but we're going to isolate the absolute value on one side of the equation. So we have to isolate it. That's important. We're going to apply the definition of absolute value and write 2 equations. So we're going to be solving 2 equations. Then we solve each and we check the solutions. Okay, and so here's the thing, we're going to check the solution and discard any extraneous solutions. I know, you're like, what? Some of them don't actually work. The next note is absolute value equations cannot be negative. It's not possible. There's no solution. Totally impossible. So what that's saying is if we have the absolute value of the quantity x plus 3 equals -7, that cannot happen. They cannot be negative. So if you get something, an equation like this, you're like, nope, not possible, and you're done. Those are the nice ones to get. Okay, I'm going to move us on up so we can start on example 2. Kind of keep those steps there to help us maybe. All right, example 2 says solve the absolute value of x plus 5 equals 9. All right, so the first thing we had to do was isolate the absolute value. on one side. Well, that's done, so check. Step 2 is apply the definition of absolute value to write two equations. Okay, so what we're going to do is we're going to say, okay, then we're going to split this off and have x plus 5 equals 9 and x plus 5 equals negative 9. Okay, because the number inside must equal, okay, because this number in here, the total in here must be 9 or negative 9 for us to get a 9 over here. It has to be equal to one of those things when we add them. That's why we have to isolate. All right, so then we're going to solve each. So we subtract 5 from both sides. We get x equals 9 minus 5 is 4. On the other equation, we subtract 5. We get x equals, now negative 9 minus 5 is going to be negative 14. So two very different answers. Okay, so that's so we did step 2 and we solved as well. So now we need to check. I didn't leave us much room to check. All right, so to check it, we're going to plug those numbers back in. Let me do that in red. So I would have 4. Let's see, the absolute value of 4 plus 5 equals 9. Well, the absolute value of 4 plus 5, so we've got 9 equals 9. That checks out. Over here, we would have negative 14. The absolute value of negative 14 plus 5 equals 9, because we're putting it back into our original equation. Okay, negative 14 plus 5 is the absolute value of negative 9. The absolute value of negative 9 equals 9. That checks out. All right, I don't remember if you remember the phrase or not, but this is, we talked about these earlier, or yesterday, so hopefully you remember. This was yesterday's lesson. But when we have to separate it into two equations and solve, like step 2, this is a disjunction. Yesterday we talked about conjunction and disjunction. This is a disjunction, just so you have that in your head, maybe. Refresher from yesterday. Okay, so if we look at example 3, this time we have 2 times the absolute value of 3x minus 12 minus 8 equals 24. So we've got some stuff, like step 1 is going to be a little harder because we have more to do. Okay, we do have to actually isolate the absolute value this time. So we're going to add 8 to both sides first, because it's the reverse order of operations, if you recall. So then we're going to have 2 times the absolute value quantity of 3x minus 12 equals 32. Then we need to get rid of this 2, so we're going to divide by 2. And that'll leave us with that isolated absolute value. So we'll have the absolute value of the quantity 3x minus 12 equals 16. Okay, so I've kind of run out of some room. So we're going to split it. Now that we have step 1 done, it's isolated, we're going to split it into 2 different parts. So we're going to say, well, 3x minus 12 is going to equal 16. Or we are also going to say 3x minus 12 equals negative 16. Since it's the absolute value, we have to do both. Remember, that's that disjunction. And then we're ready to solve. So let's add 12. So 3x equals 16 plus 12 is 28. We're going to divide by 3. X equals 28 thirds. It doesn't go nicely, unfortunately. Okay, on our other one, same steps, right? We add 12. We get 3x equals, okay, negative 16 plus 12 is negative 4. Divide by 3. X equals negative 4 thirds. Okay, then we're ready for step 4, which is the check to see if we have any extraneous solutions. Okay, so we would have, again, we have to plug our answer back into the original equation, that 2 times the quantity. So we're going to have 2 times the absolute value quantity of 3 times 28 thirds minus 12. Oh, put my absolute value sign in there. Oh, wait, no, not yet. Too early. So let me undo that. Then I put my absolute value sign. Put minus 8. Oh my goodness, I don't have enough room at all. Minus 8 equals 24. You can make that out. So my 3's would cancel, and I would have 2 times 28 minus 12 minus 8 equals 24. Well, 28 minus 12 is 16. So I'd have 2 times the absolute value of 16 minus 8. So 2 times, or the absolute value of 16 is 16. 2 times 16 is 32. 32 minus 8. Let's see, so I'd have 32 minus 8 should equal 24. And indeed, it does. It checks. On the next one, we're going to have 2 times the absolute value of 3 times our negative 4 thirds minus 12, absolute value, minus 8 equals 24. So 2 times the absolute value, our 3's cancel. So negative 4 minus 12, absolute value, minus 8 equals 24. So 2, absolute value of negative 4 minus 12 is negative 16, minus 8 equals 24. Okay, the absolute value of negative 16 is 16, so 2 times 16 is still 32, minus 8, which would give us 24 and checks out. So what I should have done for the last one, and this one I didn't do yet, I will. So we'd have x equals 28 thirds, comma, okay, because we have two x's, negative 4 thirds. Where for this one, I should have written x equals 4, comma, negative 14. Okay, I should have had both of those in there to list our solution. Okay. Let's look at example 4. Solve the absolute value of 2x plus 5, close the absolute value, equals negative 4. Wait. It says it equals negative 4. I thought absolute values could not equal a negative number. Yeah, good. Maybe you caught that. Okay, so it can't be negative. Okay, it can't be equal to a negative, so this one is no solution. That's the answer to this one. No solution. Woohoo, an easy one. Okay, let's go to the back. All right, so we're going to solve the absolute value of 2x plus 9 equals 3 minus 8x. Okay, so if you remember, the steps said we had to isolate the absolute value. It is isolated. So we are ready to go ahead and make it into that disjunction. Okay, so we can solve it because the absolute value is already isolated on the left side of your equal sign. It's not about getting our x's together yet. That's after we get rid of our absolute value. So we're going to have 2x plus 9 is equal to 3 minus 8x for one problem. Okay, for our other one, how do you think we're going to do that one? Because we need to negate it. So 2x plus 9 is equal to a negative, and we're going to say the quantity of 3 minus 8x. And we'll have to distribute that. But that whole entire quantity is negative. Okay, so now we're ready to solve. So I'm going to add 8x here. Okay, I'm actually going to go ahead and do 2 steps at once. Well, no, I'm not. I don't want to confuse you. So we've got 10x plus 9 equals 3 minus 9. 10x equals 3 minus 9 is negative 6. And divide by 10. So x equals negative 6/10, or I'm going to actually reduce this to be negative 3/5. Okay. So I try to circle my intermediate answers and then actually put a box around my actual answers when I'm done. Okay, so let's look at the next one. So now I've got 2x plus 9 equals, I need to distribute that negative sign. So equals negative 3, and a negative times the negative for the 8 would be plus 8x. Okay. So now I get to subtract 8x. 2x minus 8x is negative 6x plus 9 equals negative 3 minus 9. Negative 6x equals negative 3 minus 9 is negative 12. Divide by negative 6. It's nice that this is an equation and not an inequality. Then I don't have to worry about the negative or the symbol flipping. So x equals a positive 2. Okay, so we've got our answers. Now we're ready for the final step to check them. Okay, so let's check it. We've got the absolute value of 2 times negative 3/5 plus 9 equals 3 minus 8 times, oh my goodness, negative 3/5. I hope you guys have more room than I do. Or squeeze it in there, write it on a post-it and stick it in if you have to. Okay, so this is going to be 3 times negative 2 is going to be negative 6/5 plus 9 equals 3 minus negative 8 times 3 is going to be negative 24. So minus negative 24/5. Or you might have went ahead and made that plus. That's okay too. All right, so then I'm going to skip a little bit here because if we multiplied this by the 9 by 5, we would get 45. Right, so we could, well, here, I'll just write it. Okay, because it'd be negative 6/5 plus 45/5 would be 39/5, or the absolute value of 39/5. Then here we could change these to add the opposite, so to plus. This would be 15/5 plus 24/5. 15 plus 24 would equal 39/5. Okay, so this one checks out. So we're going to keep that one. Let's look at our next one. So we've got the absolute value of 2 times 2, because our answer is 2 this time, plus 9, close our absolute values, equals 3 minus 8 times 2. Okay, so 2 times 2 is 4 plus 9 equals 3 minus 8 times 2 is 16. 4 plus 9, so we have the absolute value of 13 equals 3 minus 16 would be negative 13. Wait. Same thing here, right? The absolute value of 13 cannot equal negative 13. This is not happening, so this is false, we might say. Or this is an extraneous solution. Okay, so it does not work. X equals negative 2 is not our answer. So our answer is strictly x equals the negative 3/5. Only one solution here. Okay. So now we're ready for looking at some distance problems. Okay, so distance and the midpoint formula. Okay, so first up, we have the distance formula. So our distance equals the absolute value of b minus a. Okay, so that's the distance between 2 points. So from A to B is our distance. The midpoint formula. We're going to add A and B and divide it by 2 to find our midpoint M. Okay, notice in our distance though, we always take the larger point and put it first and subtract them. All right, so let's get to work. Example 6 says find the length of each segment and the coordinate of its midpoint. So we want GH. So we've got G is 3 and H is 7. We want to use those formulas. Okay, practice using those. So D equals our B minus the absolute value of B minus A. So it's going to be 7 minus 3. Well, 7 minus 3 is the absolute value of 4, which is 4 is the distance. It's like, woohoo, this is easy. All right, our midpoint, we're going to use this formula, A plus B. So we're going to have 3 plus 7 divided by 2. 3 plus 7 is 10, divided by 2 is 5. So, and we might rewrite that 4 equals D here, and 5 equals the M. You've already got the M and the D here. Maybe it's easier for you to write at the end. Who knows? Now we want to do FG. So F equals -8, and G equals our 3. We already did. So this time for our distance, we're going to take, again, we're going to take the larger value. So we're going to do the absolute value of 3 minus -8. Okay, well, that's the same thing as plus a positive. So we're going to have the absolute value of 11, which is 11 for our distance. For the midpoint, we use our midpoint formula. We add and divide the 2 points and divide by 2. So we're going to take -8 plus 3 and divide it by 2. -8 plus 3 is a -5, pardon me, almost got that. Divided by 2 is going to give me a -2.5 for my midpoint. Remember, the midpoint is the middle, so -2.5 is the middle of FG. That looks right. Okay. Now we're going to change it up again, because there's a lot in this one. And we're going to write an absolute value equation representing the graph. Okay, so to do this, let's look at this box. Write an absolute value equation. The fact that the midpoint is the same distance from both endpoints can be used to write an absolute value equation. Okay, so if we have the absolute value of x minus 5 equals 2. This describes the points that are 2 units from the midpoint 5. So 5 is our midpoint. Okay, so x are the possible endpoints, m is the midpoint, and d is the distance. Okay, so this part is the distance from endpoint to midpoint. And I thought I had that on there somewhere, but I did not. So the formula is the absolute value of x minus m, close your absolute value, equals d. So you want to add that 2 there. Okay, so write an absolute value equation representing the graph. So we know our endpoints, right, are -1 and 5. So let's call those A and B. So A is -1, B is 5. Not that that's necessarily helpful yet, but we have to know our midpoint. Okay, we have to know the midpoint and to be able to write the equation. So we need to solve for the midpoint. So our midpoint equals -1 plus 5 divided by 2. So -1 plus 5 is 4, divided by 2 is 2. Okay, then, so I'm going to graph my 2. We need to know the distance. D is the distance from the endpoint to the midpoint. So that's where this D can be tricky here. All right, because it's the distance from an endpoint to a midpoint. It's not the whole distance, d. All right, so that distance is 1, 2, 3 is our d. So d equals 3. Now that we know our d is 3, we're ready to write our absolute value equation. So it's going to be x minus 2, absolute value, equals 3. So the absolute value of x minus 2 equals 3. So we know the point that is 3 units. We know the point that is 3 units from 2, the midpoint. Okay, so the points that are 3 units from our midpoint of 2. All right, so we're going to work on this a lot tomorrow in class, like in your homework. Go over some questions. I'm sure you'll have some, but I'll see you tomorrow.